In this video segment, we will just examine a bit further, just to understand a bit more on the multi-table row access using Python's SQLite connection. So here I give a little bit of a summary or comparison between cross join and inner join. We have discussed this before in the actual study of SQL using SQLite Studio. But here, with the sort of mind fresh with Python's interface with SQLite, let's just revisit this a little bit more, just to drill in the idea of cross join and inner join, because there is a bit of similarity and yet not the same usage of cross join and inner join. That is what is leading to a lot of times getting that including myself, a lot of times getting confused. So it's good to actually put them, right in front of us and face to face with each other, and then sort of really examine what are the commonalities and differences. Now, you have heard me saying cross join is like union and inner join is like intersection, and that is pretty much true conceptually. Although be careful, because union is a set concept. That means the values or the items and the rows in the unions situation is not going to be repeated. But here comes the confusion. Although we have been using cross join and inner join, and my examples have been basically rooted on very popular common usage, where we have to refer to customer ID that is being defined in another table as primary key. Cross join and inner join are not necessarily always uh, joining by the primary key and foreign keys. So when you have non-unique values, repeated values, then cross join literally repeats the repeated values and propagate the repetition. So it's going to be a lot bigger table than necessary. So in that case, the union idea of a set no longer quite describes this, because there are repeated rows. But still, I think you get the idea, right? That cross join is Cartesian product, cross product of all the rows with all the rows. That is the literally brute force way to think about it. So that is our so-called union. And inner join is definitely a subset of cross join. In other words, whatever you can do with inner join, in a way, you can cross join first, then filter off everything until you get back the same subset as inner join. Then why inner join? Because that whole sequence of cross product first, then chop off all the rows that we don't want and get back the same thing is much more compactly and obviously described by inner join these two tables on which two columns, right? One column on one table. And that is very clear, very immediately tells us what the logic of that SQL select is. So definitely think about these two clearly, but not confusing them, right? So cross product, big table, Cartesian cross product of everything. Inner join, you need to align the columns. Another distinction is that cross join doesn't care about the column content. It just brute force multiplies, right? But inner join cares about the content, because cross join, you don't really have to have a where. You don't really have to have a where. So if you don't specify a where, everything comes out, and that's possible. Inner join, you have to have an on. So that kind of forces us into thinking correctly the logic that, oops, I inner join, but I forgot to say which column. So inner join, you have to have the on to make sense of it. And because of the on, it requires, therefore, inner join to look at the content of the columns. Next, we can look at cross and inner join as expansion versus contraction. Definitely not literally, but cross join expands the table by the rows, so they cross multiply, and so you have the end result table is a much bigger table than each of the original two tables. Contract for inner join, contract may or may not actually describe it nicely, but it is giving us a sense that we are restricting this. It's like having an invisible additional where clause to filter off. So the where clause definitely wouldn't expand the rows. So definitely it's going to be contracting. So again, the end result is very different, drastically different. Next is next the usages are very different, right? So both have their own situations where they are very useful. Inner join, I've already mentioned many times that foreign key equal to the primary key, especially for IDs and codes, right? So that's very common actually. So inner join is very useful there. But of course, we can simulate the inner join with cross join, but we don't. We rather use inner join to be more descriptive. And everywhere else, all other situations, we will use cross join. Now you might be wondering, where else will we use cross join, right? Because it's just producing such vast table, and then we have to pick and choose and so on. And just continue watching. We'll have an example that is quite common and useful, and must use cross join to get the end result. So next up is efficiency. So sometimes we might be tempted to, why don't we change cross join to inner join? Because sounds like inner join is intersection, it's contracting, it's a smaller table, so should be faster, right? No, not exactly. Yeah. Um, let's put it this way: because they are used in different situations, yeah, for readability, clarity, and possibility. Because situations where cross join can be used does not necessarily imply inner join can be used. But where inner join can be used, cross join can be made to emulate the same effects. So they definitely have different uses. Where you are trying to use cross join, when you find that cross join seems to be the natural fit, then most likely it's the natural fit. You might be thinking, but then what about the efficiency? We're producing such huge table, and then we are throwing away the those rows that we don't want, right? A lot of them. Then that might seem to waste a lot of time and slow down my query. And if I have to repeat loop through for 1,000 records doing that, then wouldn't that be very slow? And that consideration is a very healthy thinking. However, SQL Server, once it sees that you're doing cross join, explicitly spelled out cross join, right? It doesn't have to literally physically produce all the possible combinations of rows. It can perform certain tricks to um, very effectively and efficiently generate only those rows that you want. So smart SQL servers can perform a lot of optimization tricks to make sure that it's not forced to literally produce all the combined rows, permuted rows, in order to address what you want. So logically, we can think of it as, yes, SQL Server performs the permutation of all rows, producing a super large table, after which we pick up what we want. We can think like that. That convenience in thought, in organizing the thinking process, is exactly what relational database is offering us. Yeah. So we can think like that, but SQL Server can implement it somewhat differently to make it efficient and yet supporting this idea. So definitely don't need to think about changing cross joins to inner join. Next, inner join might seem like a little bit faster, a little bit smaller, therefore faster. Not necessarily, because inner join definitely needs to inspect the data content and to align them. All right. And so there's a lot of looping, there's a lot of searching, there's a lot of reading back the data before it even reaches us, but not necessarily cross join, which is just blindly permuting all the rows. So the details of the efficiency of both joins is very much dependent on many factors, including how cleverly the SQL Server is being coded. So let's not fret over those concerns that we cannot change, right? So just focus on what is logically correct in describing what query we want. And the correctness of our select statement is much, much more important than the sort of consideration of using a different choice of join, when actually this consideration is not justified, yeah, because of different users and behavior. So next up, we like to perform an example, a demo, to execute select, Then double vertical bar is to link, remember the concatenation of string, link the equal sign to the content in FR type for first table, then link it to the second subtype and call the whole long string as long description. So what is it going to become? Well, FR type is whether it's balance sheet or P&L, right? So BS, and the subtype is for balance sheet, it is asset. So we have, assets, equity, liability, and so on. So we want to connect them. So we want FR type equal to subtype. And the way to say it in SQL is to, instead of plus, we use a double vertical bar. So this whole thing is one column. All right, so we select one column from account as T1, account as T2. And remember that this comma here, this comma, although we didn't say cross join, but we can think of it as cross join. So we know this is going to give us a huge table of number of records in T1 times number of records in T2. So if we have 10 records in the same table, because they refer to the ACCT table, right? So that will be 10 times 10, 100 rows of strings. And if we look at the result, a lot of them are repeated. Because remember, we are basically implementing cross-join on columns such as FR type and subtype, which are not distinct. They are not unique. We have BS, 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 right? We have repeated values of BS. Assets, we also repeat some of them, and so on. So they are not unique. When you cross-join tables on columns that are not unique, what happens? Nothing happens, except they are permuted. They are not distinct. That means we do get BS equals to asset, BS equals to asset as many times as is necessary. Okay,